This is the front of the microwave panel that I removed. And if you look at it, you'll notice it's just like any other microwave panel. We've got buttons for convenience cooking, we've got timed cooking, and so on. But that's not really the interesting part. What we want to see is the circuit board behind all of this. Now this is the back side of that panel. This ribbon cable is what actually connects the push buttons to the circuit board. So this connector here is basically just connecting to a bunch of switches, and every time a button is pressed, that switch is closed. You can see some headers here where I had to pull wires off. This was not a header. It's kind of hard to see in this photo, but this is actually a connector for the display, the time display and information display on the front. It's not sure exactly what kind it is, some type of vacuum display. I don't think it's an LCD device. There's a bunch of other things to talk about here. Let's make sure I got all the overview. Oh yeah, I'm going to zoom in a little bit more, but before I do, there's a component over here, and when you first look at it, you notice it has two bladed leads on it. You might think that it's some type of relay, but it's kind of strange because it only has two leads. Usually a relay has at least two connectors for the coil and then some connectors for the switch. Well, if you look on the side of it, what you can do, it says 220 VAC, which means that it can take up to 220 volts AC, 60 HZ, which is for 60 hertz, 10 mu F. That's the giveaway that this is a 10 microfarad capacitor, and 0.83 amp is its rating. Another thing to note, you can't see it in this photo, but off to the left side, this is apparently a fairly decent microwave. There's actually a schematic for the device. So it's kind of interesting. There's some appliances include schematics, some don't. A lot of times, especially dishwashers, if you take off the bottom panel and reach up in there or look at it, you'll usually see a schematic that's folded up and just waiting for you to come and troubleshoot it and try to fix it. Anyway, let's look at the rest of the devices on this board. There's some obvious capacitors here. These are electrolytic capacitors. Let's see, I count 1, 2, 3, 4, 5 obvious capacitors besides this big one over here. As a matter of fact, I'm going to zoom in quickly on the board so we can see it a little bit better. So those are pretty obvious. Another way you can recognize those is there's a plus minus on the circuit board, and there's a minus on one side, and they're generally can-shaped devices. These are just screws. You can't see them very well in the photo, and probably even worse on YouTube. In any case, there are a bunch of other components like this right here, all these in a line. These are obviously resistors. One way to recognize an item on a board is by the silk screen. That's what all this printing is called, is silk screen, because of the way it's printed onto the board. In any case, this printing here has an R with a number after it for each component. That's a dead giveaway that these are resistors, just like over here for these capacitors there's a C and then a number to indicate the number of the capacitor in the circuit. There's also a bunch of sort of glass red and black colored items. There's a couple here, there's one down here, there's another one here, and a couple over here. Those are all diodes. Now it's a little confusing because some of them are straightforward. They say D on them, and of course there's a black stripe indicating the cathode. So that's pretty easy to figure out that those are diodes, but then you see something that says ZD. Well, ZD means Zener diode. That's a different type of diode. It's actually made to be reverse biased in order to control voltage levels. Let's see, what else have we got? This little device down here looks like a capacitor when you first glance at it. It looks like a ceramic capacitor, but it doesn't say C on the silk screen. I'm having to look at the actual board itself rather than the picture so I can actually see it, but it says PTC1. My guess is this is some type of fuse, but if I really wanted to find out, I'd look up the number that's printed on the front of it, which is WP390M. So I'd look that up. Right next to it, above it, this white block here, my initial guess was that that was a power resistor, but I'm wrong because it doesn't have any resistance rating on it, and unfortunately the components are blocking it, so I can't tell exactly what that is. I might have to take it out to look at it, but it's either a relay, yeah, it has to be a relay. It says RY3 next to it. I was confused a little bit because this says D, and over here is a D, and here's a D, but those are these three diodes. This R here must be a relay for that device. That's what it looks like. A lot of times relays like that are black. Like for example, these 1, 2, 3, 4, 5, 6, 7. Those are all relays. And it makes sense that you need quite a few relays in this microwave because you've got to switch a decent amount of power, and a mechanical relay is a cheap way to do it when you don't have to have high frequency switching. There's another device tucked away back here that has the same symbol as this one has, and it says VR1, whereas the other one says PTC1. I believe both of these are circuit protection devices, but again, you'd have to look up the number on the component. I missed one relay. There's actually a relay right here, and you might look at it and say, well, there's only 2 blades on it. How do you know it's a relay? Since again, a relay usually has 2 connectors for the coil and then a couple of connectors for the switch that the coil pulls. Well, this relay is different from the one that was off to the left side because this relay is soldered to the circuit board. So it actually does have connection to the coil there, and then this would be the switch output. Most likely it's a normally open switch that can be closed by the coil, but we'd have to look at the schematic or play with it to find out. This big piece here is pretty obviously a transformer. You can tell that. Let's see, is there something on the silk screen that indicates it? I don't see anything, but you begin to recognize these where there's a wrap of coil here and a wrap of coil wire there. If you peel back this tape or this plastic, you can actually see the coil of wire and realize that's a transformer. There's a couple more diodes here. There's 1, 2, 3, 4. Let's see, what else? There's 5. There's another one over here. These are diodes, and you can tell because it says D next to it on the circuit, but also these even though they look a little different, they're black with a silver line to indicate the cathode. Those are also diodes, obviously. But they're different types of diodes than these. They're usually higher current diodes, and also there's quite a variety in diodes, as it turns out. But for now, all you need to know is that this 1, 2, 3, 4, 5 things are diodes. You might notice that there's a bunch of empty slots, and it looks like the circuit is not actually complete. This is the schematic symbol for a diode, and there's a D75 there, yeah, that's missing. Well, the reason that this circuit board is set up the way it is with all those extra slots for components is, it turns out, most of the time the most expensive component on a circuit board is the board itself, the board that's got the copper traces on it. That's the most expensive part to make. And so a lot of times what manufacturers will do is they'll save cost by ordering larger quantities of the same board with more features where that board can serve more than one model of probably microwave, of course, in this case. There's a device over here that's sticking up, and you cannot see it very well in this photograph. It says BZ1, which stands for buzzer. Now, this is actually a piezoelectric element, and piezoelectric elements are interesting because you can apply a voltage to them and get them to flex, and if you apply a varying voltage to it, you can actually get it to make sound, or you can make it flex and it will generate a voltage. So in this case, it's being used as basically a little cheap speaker, so this is what makes the noise and things, whatever buzzing noise or dinging noise or whatever when the microwave is done, or beeping noise probably in this case. Let's see, what are the components? There's another one over here. It says CR1. It's kind of bulging. I can't tell what that is. It's probably not a capacitor. Again, and my guess is some type of circuit protection, but you'd have to look up the numbers and letters on the side that say RT8.00GG. These devices down here are transistors. There's 2 of them, and you can tell by the circuit board it says Q. For whatever reason, Q is what's commonly used for transistors. These are just cheap little common transistors. I'm surprised there's actually marking on them. A lot of times you'll find that these things are so cheap when they're used in OEM equipment, sometimes they don't even have markings on them. Here's something that's kind of interesting up here. It's a network of resistors, most likely. That's what it looks like. It says AR4 next to it, and usually it's RN or something like that for resistor network. So I'm not 100% positive that's a resistor network, but probably. Speaking of resistors, here's a few more over here. There's some resistors down here, and the color stripes on them make it pretty obvious. There's a little bitty capacitor here. It says C10, and I'd zoom in on it, but the quality is not all that great anyhow. What else do we have? I think that's about it on this circuit. So here's some identification of components in the wild, if you will. There's a couple diodes back here you can't see. They're just little glass diodes. These 2 resistors ended up, no, there's 1 resistor here. There's some black ink marking on the circuit board, which makes it hard to see. Another Zener diode up here and a resistor here that's smaller. Another thing you'll notice, the size of the resistor, you begin to recognize the power rating of the resistor. These are probably 1/8 watt, and then this is smaller. The smaller the resistor, usually the lower the wattage rating. I had to disconnect wires here, here, and here to pull it out of the microwave. And like I said, this is not a connector. You can see a couple different places where devices like this, probably again resistor networks, would be mounted for other models. It says U01. I should probably have taken this off. You know what, we'll do that while we're talking. You haven't seen the copper trace side of this board, and hopefully I can get this off in a reasonable amount of time. But U usually represents an integrated circuit. In fact, if you look here, see how these are dual inline pins, so it'd be set up for an 8-pin chip. This says U04 next to it, so that indicates a integrated circuit right here in this space. If the circuit is whatever other their model would require that chip. Let's see, the connector up here for the ribbon cable that goes to the front push buttons is kind of interesting. You have to pull up on the upper portion to then release the cable, and that's actually something you'll need to learn how to do. A lot of the things you'll come across will have ribbon cables like this and smaller that you have to disconnect, and either you'll have to pry the upper usually it's on a hinge, you can pry it up and then the cable comes out, or you have to pull something straight out and the cable comes out. But I'll try to show this to you on the webcam. This is the front side of that board. You can see the display up here at the top, the vacuum sealed thing, and sure enough, right under here is an integrated circuit, which makes sense. I mean, we've got to have some kind of smart control for this. And so the chip, I can't read who it's made by, and if you look up, oh, there it is, LG Electronics. But most of the time, if you look up these custom ICs, you can't find a data sheet or anything on it. Something interesting you probably won't be able to see, but I'll hold this up a little closer to the webcam since I don't have a picture of it. There are actually several surface mount components on this board. And the surface mount components are these, let's see, these little bitty things here. I'm trying to point to it with my finger that says C for capacitor, or over here we've got some R for resistor components. And these are little bitty components that a lot of times are hard to recognize by sight. You have to look at the silkscreen to see what they are. But while you could reuse components from this side of the board, the so-called through-hole side, the surface mount components are usually not reusable. There are some transistors here that say Q, and there's some more silkscreen on the side that indicates things like that this component that I pointed out, this thing on the back side, shows that it's a transformer. So I'll try to zoom in on this and point it out to you. The little squiggly coils there indicate what that is. So this is the circuit board and how you can recognize some components in the wild.